So now for Fourier series, f of x is equal to a0 by 2 plus summation n equal to 1 to infinity a n cos n x plus b n sin n x, where a0 is equal to 1 upon pi integration over c to c plus 2 pi f of x dx, a n is equal to 1 upon pi integration c to c plus 2 pi f of x into cos nx dx, and bn is equal to 1 upon pi integration over c to c plus 2 pi f of x into sin nx dx. Now few examples we have already seen, right? So let me start with those examples. For example, f of x equal to x from minus pi to pi, and we are considering all these are 2 pi periodic functions, right? Then in the another example we have f of x is equal to x square, again say minus pi less than or equal to x less than or equal to pi. This is the third example, second example. And the third one, f of x is equal to x square, say 0 less than or equal to x less than or equal to 2 pi. Just try to understand the concept, right, what I am going to explain. If we draw the function f of x equal to x square, and again x square, right, let us try to draw these three functions. This is y, origin, and x axis. Minus pi to pi f of x equal to x, so say this is minus pi and this is pi, right? Then we know that the same line we have over pi to 3 pi, then 3 pi to 5 pi, the same kind of line we have. This is called the periodicity, right? Likewise over minus 3 pi to minus pi, we have same kind of thing. And you know that this function is an odd function. So this is x, this is y, this is 0. F of x is equal to x square, right? X square from minus pi to pi. Likewise for pi to 3 pi we have also the same kind of curve. Here we have 3 pi. 3 pi to 5 pi also we have the same kind of thing. Here we have from minus 3 pi to minus pi, the kind of curve we have. This function is even function, that also you know. Okay, now look at here. This is x, this is y, this is 0. This understanding is very much important in Fourier series. This is the curve x square from 0 to 2 pi, right? Say this point is 2 pi. Then 2 pi to 4 pi we have this curve. Then 4 pi to, say this is 6 pi, we have this curve. Here we have the curve from minus 2 pi to 0, right? Then minus 4 pi to minus 2 pi, we have this kind of curve. So this is the periodic function f of x equal to x square, right? This function is not even, not odd. So this is neither even nor odd function, right? Now if you try to evaluate a0 here, a0 is actually this minus pi to pi f of x dx. This is odd functions of 0, right? What is an? 1 upon pi integration minus pi to pi f of x into cosine x dx. This is odd function, this is even function, so multiplication of this is odd function, and you know that when this is odd, the integral is 0. Bn, what happened with Bn? Minus pi to pi f of x into sine nx dx. F of x is odd, sine nx is also odd function. So the multiplication of two odd function is even function. And so you can represent Bn by this 2 upon pi integration 0 to pi f of x into sine nx dx. This is Bn. Right. Therefore, what would be the Fourier series? A0 by 2, A0 is 0. So 0 by 2 is 0 plus summation n equal to 1 to infinity an cos nx. An's are 0, so 0 into cos nx is 0 plus bn sin nx. This is the only Fourier series when the function is odd. Here what happened? For even function, a0 can be represented by 2 upon pi 0 to pi f of x dx. I am writing direct. Would it be okay for you people? Okay. An. See, actually an is this minus pi to pi f of x into cos nx dx. F of x is even, cos nx is even, right? So the product of two even function is even, and therefore this is equal to 2 upon pi integration over 0 to pi f of x into cos nx dx. This is an. What is bn? 1 upon pi integration minus pi to pi f of x into sin nx dx. F of x is even, sin nx is odd, so the product of odd into even function is odd function, and therefore bn equal to 0. Now if we look at the Fourier series, then what is f of x? A0 divided by 2 plus summation n equal to 1 to infinity an cos nx plus bn into sin nx, but bn's are 0. So 0 into sin nx is 0. So this is the Fourier series for even functions, right? When the function is neither even nor odd, we have to evaluate a0, an, bn, right? And we substitute everything to this formula a0 by 2 plus summation n equal to 1 to infinity an cos nx plus bn sin nx, right? Is this clear to everyone?
Yes, sir.
Yes, good. So now again look at these two portions. Here we have odd and we have even. For odd functions, this is the Fourier series, and for even, this is the Fourier series. Now see, summation bn sin nx, bn sin nx, this one, equation 1, right? which contains only sine function. So you can say that this is Fourier Sine series. Fourier Sine series. Equation 2 contains a0 by 2 and summation an cos nx. Right. Now see, a0 by 2, when x equal to 0, or you can say n equal to 0, then cos 0 into x is 1. Right. So a0 by 2 is the coefficient of cos 0x. Coefficient of cos x is a1, coefficient of cos 2x is a2, coefficient of cos 3x is a3. So equation 2 contains only cosine terms, right? So that is called Fourier cosine series. Fourier cosine series, right? So actually, what is Fourier sine series and cosine series? Fourier sine series and Fourier cosine series. Let me explain by the example. Suppose I have given this graph. I have given this graph y x 0. So this is x square over 0 to pi. I have given this f of x equal to x square from 0 to pi. I want to write the function for minus pi to 0. I want to write this, right, using this x square. So I have two choices. Either I can make this function even. So for even, I must draw in this way, right? So this is also x square. Let me draw with blue color. Then this function is even function. So what I have given? I have given the function only on half interval. Only on the half interval I have given the function. On other half interval, I am assuming the same function. Whether here in this side, I have given the function x square 0 less than x less than pi, right? And I am constructing its negative minus pi less than x less than 0. So its negative becomes this. Then this function is odd function. So in Fourier sine series and cosine series, what we are doing, we have given the function on the half period, on the other half period, we choose the function, right, for even nature or odd nature. If we choose the odd nature function, right, then it gives us Fourier sine series. If we choose even nature function, then it gives us Fourier cosine series, and the formulas are these, right? So for Fourier sine series, f of x is equal to summation n equal to 1 to infinity bn sine nx, right? Where what is bn? Bn is equal to 2 upon pi integration 0 to pi f of x into sine nx dx. That is what we have discussed here. Bn equal to 2 upon pi integration 0 to pi f of x into sine nx dx. Right. For Fourier cosine, we have f of x is equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx, where what is a0 is 2 upon pi integration 0 to pi f of x dx, and an is equal to 2 upon pi integration 0 to pi f of x into sine nx dx. This is what you have to learn in Fourier series, right? So all the things we have in the Fourier series. Again I repeat, let us start from the definition. This is the Fourier series, right? Where a0, an and bn I have defined. Then for a particular function, we can say that either function is even or function is odd, or neither even nor odd, right? If function is odd, then what is a0, an and bn? When function is even, then what is a0, an and bn? And therefore, what about the Fourier series? Then we apply the same concept to find Fourier Sine series, to define Fourier Sine series and Fourier Cosine series. So Fourier Sine series and Cosine series are what? Where the function is defined only on the half interval, right? So the same function we write as a Fourier Sine series or Fourier Cosine series under the assumption whether the function is even or odd, right? Okay. So this is the half part of the Fourier series. Now the question arises, we have discussed only these kind of functions, f of x, where f is 2 pi periodic, is 2 pi periodic. So the question arises in our mind that in place of 2 pi periodic function, can I talk about 2L periodic function? 2L periodic functions, right? So if f of x is 2L periodic function, then what about its Fourier series? So let us define 2L periodic function. Okay. So the next thing is Fourier series for 2L periodic functions. 2L periodic functions. So let f of x be a 2L periodic function with the fundamental domain c to c plus 2L. There we were writing c to c plus 2 pi, right? Here we are writing c to c plus 2L. Then piecewise continuous, piecewise continuous. Then Fourier series representation of f of x is same thing. We have a0 by 2 plus summation n equal to 1 to infinity an cos nx આવું લખતા હતા આપણે nx. Here we are writing n pi x upon l plus bn sin n pi x upon l. This is the only change where a0 is equal to 1 upon l integration over c to c plus 2l f of x dx. This is a0 an 1 upon l integration c to c plus 2l f of x into cos. In place of nx we are writing n pi x upon l dx, and bn is equal to 1 upon l integration over c to c plus 2l f of x into sine n pi x upon l dx. I hope this is clear. The definition is clear. Now, if we look at the cases when f of x is even, suppose f of x is defined for f of x is defined for minus l less than x less than l, and it is 2l periodic. It is 2l periodic, right? Case number 1, f of x is even. Case number 2, f of x is odd. Can anyone help me? How do you write f of x when it is even? What is a0 and an? So a0 is equal to 2 upon l integration 0 to l f of x dx. This is a0. What is an? 2 upon l 0 to l f of x into into cos n pi x upon l dx. And what is f of x? a0 by 2 plus summation n equal to 1 to infinity an cos n pi x upon l. When f of x is odd, you know that bn's are 0, right? When f of x is even. F of x is odd, a0 is 0, an's are 0, and what about bn? 2 upon l integration 0 to l f of x into sine n pi x upon l dx. And f of x is this summation n equal to 1 to infinity bn into sine n pi x upon l. See, only one screen is enough to refer the definitions of Fourier series, right? When L equal to pi, it is 2 pi periodic function. If you substitute L equal to pi here, then pi and pi will be cancelled out. So everywhere we have nx. So 2 pi periodic function is the special case of this. Now, what about Fourier sine series and cosine series? What about Fourier sine series and cosine series? F of x is defined for 0 less than x less than L. F of x is defined only on half interval, keep in mind. Only on half interval. Right. Then the Fourier sine series. Fourier sine series and Fourier cosine series. Fourier cosine series. What can you say? Fourier sine series is the case when f of x is odd function. So here bn's are defined 2 upon L, 0 to L, f of x into sine n pi x upon L dx. And what is f of x? Summation n equal to 1 to infinity bn into sine n pi x upon L. For Fourier cosine series, a0 is defined as 2 upon L, 0 to L f of x dx. An's are defined 2 upon L, 0 to L f of x into cos n pi x upon L dx, and f of x is a0 by 2 plus summation n equal to 1 to infinity an into cos n pi x upon L. Right. If you take screenshot of this page, then easily you can refer Fourier series for when f of x is even function, odd function, Fourier sine series, Fourier cosine series. Right. Okay. Let us discuss one example. Exercise. Find the Fourier series of f of x equal to x square where 0 less than x less than 2, and f of x is 2 periodic function for all x. See, 0 less than x less than 2 pi, that example we have already discussed. Right, here in place of 2 pi we have given 2L. Right, so this is 2L periodic function. F of x equal to x square, 0 less than x less than 2. Let us compare this with 0 less than x less than 2L. Therefore, we have 2 is equal to 2L. Therefore, value of L is equal to 1. Right? Now, what we know, the Fourier series, we know that this is how do you write in the examination. We know that f of x is equal to a0 by 2 plus summation n equal to 1 to infinity an cos n pi x upon L plus bn sin n pi x upon L, where a0 is equal to 1 upon L integration 0 to 2L. See, in the definition I was writing C to C plus 2L. Right. Now everywhere no need to mention that C to C plus 2L. The fundamental domain is this 0 to 2, 0 to 2L. Right. So you can write 0 to 2L f of x dx. An is equal to, or if you are writing in the sense of definition, then just write C to C plus 2L. In An's also 1 upon L C to C plus 2L f of x into cos n pi x upon L dx, and for Bn this is equal to 1 upon L C to C plus 2L f of x into sine n pi x upon L dx. Right. We know that L equal to 1. So what is f of x? A0 by 2 plus summation n equal to 1 to infinity an cos n pi x plus bn sin n pi x. Right. This is equation 1, where a0 is this. What is a0? L equal to 1. So this is integration 0 to 2L f of x dx. Should I write 1 upon 1 here for more clarification? L equal to 1. So this is 2 into 1. Right. 0 to 2 f of x is x square dx. What is the integration? X cube by 3. The limit, lower limit is 0, upper limit is 2, and so this is 8 cube is 2 cube is 8 upon 3. This is the value of a0. a0 is equal to 8 upon 3. What is an? 1 upon L, L equal to 1, 0 to 2 f of x into cos n pi x upon L, L is 1. So this is 0 to 2 x square into cos n pi x dx. How do you integrate this quantity? This is u, this is v. Apply general rule of integration by parts. So u as it is, integration of v sine n pi x upon n pi minus sine derivative of x square is 2x. Integration of sine n pi x is minus cos n pi x upon n square pi square, because 1 n pi already we have. Opposite side, that is plus, derivative of 2x is 2. Integration of this is minus sine n pi x upon n cube pi cube over the limit 0 to 2. Again I repeat, how do we proceed? U as it is, then the derivative of u, again derivative of this bracket, right? V as it is, sorry, integration of v, then again integration of this bracket, integration of this bracket. Alternative opposite sign we have started with plus, so it's opposite sign, again it's opposite sign. Over the limit 0 to 2. Okay. So now if we substitute the limit, then see x equal to 2, so 2 square is 4. 4 into sine 2 n pi. What is sine n pi? Sine n pi is 0. So sine 2 n pi is also 0. Right, so this is 2 square is 4 into 0 is 0. This is minus minus plus 2, x equal to 2. So 2 into 2 is 4. Cos 2 n pi. Cos 2 n pi. What is cos n pi? Is minus 1 raised to n. So cos 2 n pi is minus 1 raised to 2n, which is 1. Right, so this is 4 into 1 upon n square pi square. Again we substitute x equal to 2, so sine 2 n pi is 0, so this is 0, minus sine 4 lower limit. When x is equal to 0, this term is 0, x is equal to 0, so this term is also 0, x equal to 0, sine 0 is 0, so this is 0. So what is an? Therefore an is equal to 4 upon n square pi square. This is the value of an. Now let us evaluate bn. What is the formula for bn? 1 upon L integration over c to c plus 2L f of x into sine n pi x upon L dx. Right? L equal to 1, the domain is 0 to 2, f of x is x square, so this is x square into sine n pi x dx. Now integrate this quantity just like we integrate this quantity, x square into cos n pi x. So what it be? It would be, this is u, this is v. Again u as it is, integration of v. So what is the integration of sine n pi x? Is minus cos n pi x upon n pi. Right. We are starting with plus sign, so opposite sign. Derivative of x square is 2x. Integration of this bracket, minus cos n pi x upon n pi. What is the integration? Minus sine n pi x upon n square pi square. Opposite sign, so that is plus. Derivative of 2x is 2. Integration of this, minus sign we have. Integration of sine is minus cos, so minus minus plus cos n pi x upon n cube pi cube over the limit 0 to 2. So this is the integration of x square into sine n pi x. So this is equal to, if we substitute x equal to 2, then 2 square is 4, cos 2n pi is 1, that we have seen here, cos 2n pi equal to 1, right? So this is minus 1 upon n pi. This is minus minus plus. 2 into 2 is 4, but sine 0 is 0. So actually it is 0. Plus 2, cos 2n pi is 1, so 1 upon n cube pi cube. Minus sign for lower limit, x equal to 0, so this is 0. X equal to 0, so this term is also 0. X equal to 0. Then cos 0 is 1, so this is 2 upon n cube pi cube. Keep in mind, this term will not be 0. Right, so here 2 upon n cube pi cube minus 2 upon n cube pi cube will be cancelled out. And therefore, Bn is equal to minus 4 upon n pi. This is Bn. And so what is the Fourier series? F of x is equal to a0 divided by 2. That is the formula, right? a0 by 2 plus. What is a0? 8 upon 3. So 8 upon 3 by 2 is 4 upon 3 plus summation n equal to 1 to infinity an. What is an? 4 upon n square pi square. 4 upon n square pi square into cos n pi x upon L, L is 1, plus Bn into sine n pi x. Right? If you want, you can take 4 common from the summation quantity. You can take pi common also. So this is 4 upon pi, summation n equal to 1 to infinity 4. We have taken 4 common. So this is 1 upon pi n square cos n pi x minus 4 upon pi we have taken common, so 1 upon n sine n pi x. This is the Fourier series of x square when the fundamental domain is 0 to 2. A0 is equal to 8 divided by 3, and therefore A0 divided by 2 is 8 divided by 3 by 2, so this is equal to 4 divided by 3. And that's why here we have x square equal to 4 divided by 3.